Okay, good morning. I'm getting ready to unbox my EMS HW50C. It's a surge protection device, and if you look at my chart, that's where my plug comes in from the outside, and the very first thing, that yellow, is the surge protector. Okay, so I'm going to unbox that right now and see what we'll see. One hand, we got the instruction manual, and we've got the unit. Seems to be a theme with most stuff that I'm buying. Assembled in Mexico. Okay. And it's a very simple device. It's got one screw holding the cover on it. And I don't have a screwdriver, so I'm not going to take it off, but it's pretty simple. You got your line input, and you got your output. Okay, so if you remember the chart, we come from the plug to the surge protector and then into the automatic transfer switch, which is this thing right here. And again, it's got surge protection built in it as well. Okay. So, let's open that puppy up. All right, it's nicely packed. I'm not going to take it all the way out of the box, but you get the idea. What this basically does is, this right here, this is the transfer switch. You've got your utility power, your plug from the power source comes in, and you've got your generator that goes in. If your utility power or whatever is not available, power outage, you just don't have a place to plug it in, then you turn on your generator, and the automatic switch sends the power to the service panel. That's that gray panel I have hanging in my utility room. If the power comes back on, let's say you have it plugged in, let's say you're at a campground, well, the generator, if it's on and providing power, will automatically stay in generator mode, because you don't want shore power and generator power feeding your panel. Something bad will happen. So the moment that you turn off the generator or stop supplying power to the generator side of the automatic switch, and there's shore power available, then it will kick in and provide power. But if you turn the generator on while that's plugged in, then the generator takes precedence through the automatic transfer switch and provides power. This way you don't end up with two sources of power coming in. So that's the purpose of an automatic transfer relay switch. All right, let me unbox that. I want to see it. I'll be right back. Okay, I went ahead and took the transfer relay switch out of the box. I just wanted to show you that when this is installed, it's got LEDs. This will show you where the source is coming from to let you know that you're running on shore power. So if the power went out, that would go off. If your generator is turned on, then this won't be kicked in. If they're both providing power, the generator always takes precedence. Okay? And it's got some LEDs to let you know that, you know, something's wrong, something's gone amiss. But we'll look at that later. And you can see it's got some nice heavy-duty inlets. The wire that we're using is some pretty thick stuff. Okay, so it's not marked on the metal box, but one side will be for generator coming in, and the other one will be for shore power coming in. And then, of course, when it leaves the box, it'll go, when it leaves here, then it will power up the 50 amp breaker that's in the service panel there. Okay, so this is a 50 amp system. The whole trailer is a 50 amp system. I went ahead and opened up this box too. I wanted to show you what this device is. And what this is what charges the batteries. Okay. This is the converter. This is what takes the 110 or shore power or generator power and converts that power to 12 volts. Okay, so your input 105 to 130, which we all know it is 110, 120, and it converts it to DC power volts. So the output is 13.6. I purchased a 100 amp converter because I'm going to be charging initially 4 batteries, but up to 10 batteries. Okay, actually 8. It doesn't matter. But at 100 amps, let's assume you take those batteries and you divide them by 100. It doesn't mean that, you know, if I have 10 batteries that is 10 amps each, but there's 10 amps spread out across those 10 would be 10 amps each. Doesn't mean that that's how much is going to go into the batteries, because there may be some other devices that are running at the same time. But in the real world, each battery could be supplied with 10 amps. Could be 9, 8, 7, 6, 5, whatever. It doesn't matter. But as long as this unit's powered up, it will provide 12 volts DC, which goes into the batteries. Okay, and that's what you hook up right there. All right, and it's got your ground. Or is that the neutral? That might be the neutral. I don't know. Can't see. Let's tilt it up and take a look. Yeah, that's the ground right there. All right, so you got to ground the box. It's well fused. 40 amp fuse is built in. Okay. Very, very nice. It's a new unit that they just came out with, and it's a 4-stage battery charger, which we'll get into that later, but it's pretty cool. But anyway, from this unit, you plug in your batteries here, okay? Positive, negative, I think that's what it says. I'm gonna lift it back up again. Positives on the right and the negatives on the left. Okay, no big deal. But those go to your batteries, and that will keep those batteries charged. All right, so that's what that's for. Everything in a 12-volt system comes from the batteries. So all of your charging, whether it's solar, wind, water, hydro, or this converter, all of it goes into the batteries and stores it. Then the energy is pulled out of the batteries to power up the devices that are, 12 volt. So, you're constantly putting power into the battery so that it can be utilized. That's all. Your battery is your storage. Let's see. So, on this converter, you'll notice that it simply plugs in. Okay. So, in my circuit panel, in my main panel, there will be a breaker that's 15 amps. But I'll probably put that on a 20 amp breaker. Maybe 15, it just depends what the requirements is. I'll have to read the manual. I put 15 here, but so there will be an outlet somewhere on my utility room wall specifically for this unit, okay? Now, why is it in the main panel as opposed to in the sub panel? Okay, here's why. Because you only want this unit to run if it's getting power from utility or from the generator, okay? Because what it's doing is charging the batteries, which is not on this chart, but let's say the batteries are down here. Okay. If my converter breaker and plug were in my sub panel and I were powering this unit, then that unit would be charging the batteries. Now remember, my batteries, when I've got no power up here, is running my inverter. And we all know what the inverter is. That takes the 12 volts and converts it to 110. Whereas the converter converts it from 110 to 12 volts. Okay. So it wouldn't be smart to use your battery power in your inverter and run the inverter, which is 110, to charge this to charge back in the batteries. You'd be in a loop that doesn't make sense. Okay. So if we lose power here, we don't have a generator and we don't have shore power, then we're going to be running off the inverter. And the inverter is at 110, which pulls its power from the batteries to give you 110 for your devices that need 110. Now, what sort of things would be in the sub panel? Microwave, maybe the TV, the air conditioning, and the heating system. Okay. So those devices will be in the sub panel and they will be powered by the inverter. Okay. Now I have two of these units because one is for my main utility power and generator. When I don't have either of those, I need an automatic transfer switch here that I'll either be running off my inverter or my main power system here. I know it's a little bit confusing. But remember, the generator takes precedence. So you have to look at this as the generator, because it's the power source powering this switch, which sends power to this. So when all of the systems are working properly, both of these panels are live, because some of these circuits and these circuits, when we have shore power, we want all of it working. When I don't have this part, I need this to be powering this, not that. Okay. Remember, the generator takes precedence, so if there's no power here, it thinks this is a generator, it just shuts off because there's no power coming in. So all my power will be coming from my inverter to give me power for these 3 or 4 circuits. It'll make sense more later. All right. Well, that's my story, and I'm sticking to it. I'm going to leave this stuff out because I'm going to read the manuals later and make some notes. You know, I can't say enough. I mean, I read this stuff. It's like the Bible to me. There's a reason they put this in here, and warning, avoid possible injury or death. And that's my goal, is to try to avoid injury and death. All right, it's about 5:30 in the morning. I'm going to drink some more coffee, and then I'm going to take a nap, and then I'm going to go to Lowe's. All right, I'll see you guys later.